In this video, I'm going to be talking to you about significant figures. There's a number of rules that we use to determine the number of significant figures in any given value. So those rules are as I'm about to suggest. Any number, any digit that's not a zero is significant. So all non-zero digits are significant. So what that means is, in a number like 23.5, all of the digits are not zero, the 2, the 3 and the 5, so there'd be 3 significant figures in the number 23.5. The next rule is zeros between two significant digits are themselves significant. So zeros between significant digits are significant. Okay. A zero after a decimal point at the end of a number is also significant. Is significant. And lastly, zeros that are used only to space a decimal point are not considered significant. Not significant. So let's do some examples. The number, as I said, 23.5 has 1, 2, 3 non-zero digits, so they're all significant. So the number of significant figures is equal to 3. 408.3 has 1, 2, 3 non-zero digits, and the 0 lies between two digits that are significant, so that's also counted as significant. So we've got 1, 2, 3, 4 significant figures. .0, we count the zeros after the decimal point at the end of a number as being significant. So 5.0 has 1 non-zero digit, and the 0 is after the decimal point at the end of the number. So the number of significant figures for 5.0 is 1, 2. The next one we'll do is the number 100. In this case, zeros used to space a decimal point are not counted as significant, and we consider these 2 zeros at the end as simply there to position the decimal point 2 spaces after the 1 in the hundreds column. So the number of significant figures is 1. We'll do another one. Let's say 1050. Here we've got two non-zero digits and one zero that lies between two non-zero digits. So the number of significant figures is equal to 3. And that's how we calculate the number of significant figures. The reason that this is a useful thing to know is that if we're given two values that need to be operated on in a calculation or in a problem, then let's do a little example. So when we're using significant figures, what we need to remember is when we give our answer to any given problem, the answer should be given to the same number of significant figures as the least number of significant figures in any of the values that we've used in our calculation. For example, if we wanted to calculate the area of a rectangle that's given as 1.02 meters long by 0.1 meters wide, we just calculate our area, length times width, 1.02 times 0.1, and we'd get 0.102. But what we need to do is consider how many significant figures were given in each of these two values. In the first value, 1.02, we've got two non-zero figures plus a 0 in between those. So that will be 3 significant figures. In the second value, we're only going to have one significant figure. So what that means is when we come to express the solution to our problem, we can only include this same number of significant figures as the number of significant figures in the value that has the least number of significant figures in our measurements that we've used, or in our values that we've used to come up with our answer. So in this case, we can only express our answer with one significant figure. So our answer will be 1 square meter, 0.1 square meters. Alright, so the 0 and the 2 we're not going to include because we can only use the same number of significant figures as the value that has the least number of significant figures comprising the values that we use to calculate our answer. And that's how we use significant figures.